Hello everyone, welcome back. In this video, we are going to look at problem A from Codeforces Round 838 Div 2, and the name of the problem is Divide and Conquer. So, according to the problem statement, it is given that an array is considered to be good if the sum of elements of the array is even. So, we will be given an array consisting of n positive integers, and in one operation, we can select any index I, and we can change the element at that index to a of I by 2, so closed division. So we need to find the minimum number of operations required to make the given array good, and it is always possible to make the array good, and we need to find the minimum number of operations required to do so. In the input, we will be first giving the number of test cases, and in each test case, we will be in the first line we will be given the size of the array, and in the second line we will be given n space separated integers representing the elements of the array, and we need to output the minimum number of operations required to make the array good. So this was the problem statement. Now let us move to the approach of this problem. So our target is that we want the sum of all the elements in the array to be even. Now, before moving to the approach, let us first look at the operation given to us. So in the problem statement, the operation which is given to us is that we can convert any particular number to num by 2, and the division will be closed division. Okay. So this is the operation given to us, and we can perform this operation any number of times on our elements. And the thing is, this operation of floor division of a number by 2 is equivalent to performing right shift operator on that number one time. So this operation is equivalent to performing right shift operator on that number one time. Okay. So if we right shift a number one time, then it is equivalent to dividing that number by 2. So we must keep this in mind, because this will be helpful in building logic. Now coming to the approach to solve this problem, there are a couple of observations that I want you to keep in mind. Firstly, we want our target is that the sum of all the integers in the array should be even. So if all the elements in the given array are even, then it means that the sum will already be even. Okay. For example, if the array given to us is 2, 2, 2, as the elements of this given array is even and there are no odd elements, hence we can say that the sum of elements of this array is also even. Hence we don't need to perform any operation, and we can simply print 0, as it requires no operation to make the array good. So this was the first case where all the elements in the given array are already even. Now second case is that if the number of odd integers in the given array is even. So in this case, let us consider this given array. Here the number of odd elements are even. There are 4, 3, and there are odd number of odd elements. There are even number of odd elements. So whenever the number of odd elements in our array is even, then also we can say that the sum of the elements in our array is even. As you can see, 3 plus 3 plus 3 plus 3 is 12, plus 2 is 14. So this was the second case where whenever the number of odd integers, so it can be 0 also, 0 is also included. If the number of odd integers in the given array is even, then also the sum of the elements of the given array will be even, and In this case also we will not perform any operation and we can simply print 0. So this was the second case. Now coming to the third case, what if the number of odd elements in the given array is odd? For example, if the array is something like 3 comma 3 comma 3 comma 2. So in this example the number of odd integers is odd, and if we calculate the sum it will be 3 plus 3 plus 9 plus 2 is 11. So the sum is not even. Whenever the number of odd elements in our array is odd, then the sum will also be odd, but we want our sum to be even. So to make the sum even, we need to perform some operations. Now how we will how we will overcome this? We need to make the number of odd integers in the array even in number. Currently the number of odd elements is odd. We need to make the number of odd elements even in number. So for that we have two options. So this is the main logic actually. So in this case we need to make the number of odd elements even in number. For that we have two options. We can either reduce the count of odd elements. So if we do so, we can reduce the count of odd elements by 1. If we do so, the number of odd integers will again become even. Previously there were odd number of odd integers. Now if we reduce the count of odd elements by 1, it will become even in number. And then because of that the sum of elements will become even. And the second option which we are having is that we increase the count of odd elements. So if the number of odd elements in our array is 3, and if we increase the count of odd elements by 1, it will become 4, and now odd elements in our array are even in number, and hence the sum will also become even. So these are the two options which we are having. We can either reduce the count of odd elements, and we can either increase the count of odd elements. In both the cases the number of odd elements will become even in number, and hence the sum will also become even. Now we need to, in order to do this, we will perform our operation on the elements. Now what we are going to do is we are going to find the minimum number of operations required to firstly reduce the count of odd elements by 1. So let's say number of operations required to reduce the count is x. Then we are going to find the number of operations required to increase the count of odd elements. For that also we need to perform some operations. Let us say the minimum number of operations required to increase the count of odd elements is y. So after finding x and y, our answer will be minimum of x comma y. Okay, so what we have done here is we are first finding the minimum number of operations required to reduce the count of odd elements in the given array. For that we perform this operation on some element or elements, and this number is x. Then we again iterated through the array elements, and we found the minimum number of operations required to increase the count of odd elements. For that also we performed some operations, and the minimum number of operations required is y. After finding x and y, our answer will be minimum of x and y. So whichever takes less number of operations to make the number of odd integers even, that number of operations will be our answer. So I hope it was clear. Now coming to the second part of our logic, we need to find how we are going to find this number of operations required to reduce the count of odd elements. Okay, and then later we will see how to find the number of operations required to increase the count of odd. We need to change any odd number in the given array, and we need to change the number to even. So for that we will be iterating through the given array, and for each odd number we are going to find the number of operations it takes to convert that number into an even number, and whichever odd number takes minimum number of steps or operations to become an even number, we will save that, and that will be our x. Okay, so for example, if we are having odd number 5, we need to find how many operations it will take to change this number to even number. We will perform this operation given to us. We will perform floor division and divide it by 2. So it gives us 2. So as you can see, it only takes one operation. Now, instead of performing actual division on our elements while iterating through the array, what we are going to do is we will convert the odd number into its binary form. So binary of 5 is 101, and we are going to start checking it from the rightmost end. So rightmost bit is set because it is an odd number. So basically, the number of steps an odd number will take to become an even number, we can find that by the number of consecutive set bits from the rightmost end. So here there are only one set bit, consecutive set bit. It means that if we perform right shift operator, it will become this 1 0. Okay, now as the rightmost bit is 0, it means that the number has become even after performing one right shift operator, and this right shift operator is equivalent to performing float division by 2. So hence we can say that it only takes one operation to make number 5 an even number. So after performing right shift operator, 5 will become 2, and it only takes one operation. Okay, so this was an important observation here. We are going to iterate through the array elements. For each odd element, we are going to find the number of operations it takes to become an even number. For that, we are going to find the binary form of that odd number, and then we are going to find the number of consecutive set bits starting from the rightmost end, and that will tell us the number of operations required to make that odd number into an even number. Now let us see this 7. 7 is also an odd number. Now if we divide 7 by 2, it gives us 3, which is not an even number. We will again perform another operation, and it gives us 1, which is also not an even number. We will again perform the operation. It gives us 0. So now it is an even number. Okay, because the binary of 7 is 111. So as you can see from the rightmost end, there are 3 consecutive ones. It means that it is going to take 3 operations to make this an even number. After performing 3 operations, the binary string will get, so after performing 3 operations, the binary string that we will get will be 0. Now as the rightmost bit is 0, it means that the number has become even. Okay, so here it takes 3 operations to make 7 an even number, and we are going to do this for all the odd numbers, and whichever number takes minimum number of moves or operations to become an even number, that will be our x. Same thing we are going to do to increase the count of odd elements. To increase the count, we are going to change any even number to an odd number. Okay, so it will be same process. For each even element, we are going to find the number of operations it takes to become an odd number. For that, we will perform the operation given to us. So for example, this 4 is an even number. We need to change it to an odd number. We will perform the operation one time, it will become 2. It is again even number. We will perform the operation and it will become 1. So it takes 2 operations to change the number 4 into an odd number. And as you can see, binary of 4 is 100, and so basically the number of consecutive zeros from the rightmost end tells us the number of operations it will take to become an odd number. So after performing two right shift operations, the binary string will become 1, and as the rightmost bit is now set, it means that the resultant number is now odd in number. The resultant number is now odd. Hence, the number of odd elements which means the number of odd elements has increased in our given array, and that's what we want. So we'll iterate through the given array, and for each even element, we are going to find the number of operations it will take to change that even number into an odd number, and we are going to keep track of the minimum number of operations, and that will be our y. As we have discussed, our answer will be minimum of x and y. So this was the logic. Now let us look at the code. So this is the code. After taking in the input, which is the size of the array and the array elements, we are firstly iterating and finding the number of odd elements in the given array. If the number of odd elements in the given array is even in number, it means that the sum of the elements is already even, and hence we are printing 0, as it requires no number of operations, and we will return. If the number of odd elements in the given array is odd in number, it means that the sum is not even, and then here we are finding our x and y, as we discussed before. Minimum steps required to make an odd number even, which will reduce the number of odd elements and make it even in number, and minimum steps required to make an even number into an odd number, which will increase the number of odd elements by 1 and make the number even. Okay. So we have initialized both these variables at 32 because at max there are 32 bits in the binary representation. Now we are iterating through the array elements. We are finding the binary representation of that number, and I have reversed it for the ease of my logic, and I have taken this count variable. If the element is odd, I am finding the number of operations it will take to change that odd number into an even number, and I am keeping track of minimum number of operations. Similarly, if the element is even, I am finding the minimum number of operations it will take to change that even number into an odd number, and again I am keeping the count, I am keeping the minimum number of operations it will require. Okay, so after iterating through all the elements in the given array, our answer will be minimum of these two. These two are our x and y, as we discussed in our approach, and this will be our answer. So if I run this code, it gets accepted. Now let us try to submit this also. So if I submit this code, so as you can see, it gets accepted. So this was the solution to solve this problem, and I hope it was clear. Thank you.